All right, now we're going to write up the whole goodness of fit test. And so first, we're just going to remind you on what the topic is about. We had a random sample of accidents throughout the week, and we wanted to determine if we have evidence that the accidents are vary by day. So our null hypothesis in this situation is that they don't change. The proportion of accidents, you could even say all accidents, because we should be talking about the parameter, accidents for each day is the same. Now, I'm just reminded how terrible my writing is with this, so how about I type this next one? I'd say, just for alternative, is that the proportion of all accidents for each day are not the same. Great. Now when we go to conditions, we have to check data come from a random sample. Great. And here we can just say all expected counts are greater than 5. If all are greater than 5, then we're good to use the chi-square test. So now we want to look for the p-value and interpret. Well, back on our previous video, we found our x-squared value to get 208.85. And there are 7 things. So our degree of freedom, we say k minus 1. So our degree of freedom, there are 7 categories. And if I subtract 1, our degree of freedom is just 6. So now let's look back at those charts. And I'll show you how to read it off of a chart. And then we'll go from there. Our degree of freedom is 6. So we're looking at this row here. And our chi-squared value, we look for a chi-squared value that's 208. If I go along here till I get a chi-squared of 208, it doesn't exist. So we know that 208 is way less than a p-value of 0.005. So in this case, our p-value is essentially 0. So in our interpretation, we reject the null hypothesis because our p-value is below alpha equals 0.05. So we have evidence that the proportions of accidents on each day are not the same. And that's it. Now, when we are doing our significance test, what we can look at is use our calculator to find that value. So when we use our calculator, we want to use a chi-squared distribution. So if you hit second vars, you'll find a chi-squared CDF. So in your calculator, you can do chi-squared CDF. It's just a different distribution, like a t distribution, a normal distribution. And what we'll take is our first value, 208, and then we always go to infinity, comma, degree of freedom. So this is your x squared max degree of freedom. So if I did that, I got 208, comma, big number, comma, degree of freedom 7. It's a very, very low 0. I got 2.3 times 10 to the negative 42nd. So that's essentially 0. All right, hopefully that helps you with your on your owns.